Japanese motorcycle engineers do not build machines. They build philosophies. Every bolt torqued to specification, and every oil passage machined to a tolerance measured in thousandths of a millimeter. After decades of research, I am exposing 19 secrets that the dealership service manual buries in footnotes. The 19th secret on this list is the one that Japanese factory technicians consider the single most important maintenance act a rider can perform. Most riders do it completely wrong. Every time. 19 secrets, zero compromise. Let us begin. 19. The cold start protocol. Every time a rider starts a cold engine and immediately twists the throttle, they are forcing metal components that are dimensionally smaller than their operating specification to work against oil that is thicker than its operating viscosity, while generating heat faster than the cooling system was designed to dissipate from a standing start. The microscopic damage to bearing surfaces, valve guides, and piston skirts from this single destructive habit accumulates invisibly over years, compounding with every cold start. By 40,000 kilometers, it is visible on the components. By 60,000, it is audible. The Japanese cold start protocol is this: start the engine, set it to idle, and do not ride for a minimum of 90 seconds in warm climates, 2 minutes in cool climates, and 3 minutes when ambient temperature is below 10 degrees Celsius. Do not blip the throttle. Do not rev it to clear the pipes. Let the oil pressure build. Let the temperature rise. Let the metal expand to its designed operating dimension before you ask it to work. This single habit, applied consistently, is responsible for a measurable percentage of the mileage gap between engines that last and engines that do not. You survived the cold start. Congratulations. Now the manual is about to lie to your face, and it will do it with such confidence, you will probably thank it afterward. 18. The oil change interval deception. The owner's manual says 6,000 kilometers between oil changes. That number was not chosen by the engineering team. It was chosen by the marketing team after the engineering team submitted their recommendation, and the marketing team decided the service interval needed to match the competition's advertised figure. In multiple documented cases from factory technical bulletins, the engineering recommendation for full synthetic oil in a high-revving 4-cylinder motorcycle engine is between 3,000 and 4,000 kilometers under normal conditions. The secret is not to change the oil more expensively. The secret is to change it more frequently with the correct viscosity grade for the ambient temperature range you actually ride in, not the single grade listed on the filler cap. More oil changes. Got it. But wait, are you even using the right liquid? Because the next secret reveals that the green stuff in your radiator is quietly eating your engine from the inside. Every single day. 17. The coolant chemistry rule. Every Japanese motorcycle manufacturer specifies a coolant type in their technical documentation that is almost universally ignored at independent service shops. The specification is not a preference. It is a corrosion chemistry requirement. Japanese aluminum alloy cylinder heads and water pump impellers require a phosphate-free, silicate-free coolant formulation to prevent galvanic corrosion between the aluminum castings and the steel water pump shaft. Generic green antifreeze, the type sold at every petrol station and used by the overwhelming majority of independent mechanics, contains silicate compounds that deposit crystalline scale on aluminum surfaces at operating temperature. Over 3 to 5 years, this scale insulates heat transfer surfaces, raising operating temperatures, and erodes the aluminum surface underneath when the scale flakes away under thermal cycling. Honda, Yamaha, Kawasaki, and Suzuki all specify OAT, organic acid technology, coolant, or their proprietary equivalent. The color is typically blue or pink. The price difference compared to generic coolant is minimal. The difference in aluminum surface condition at 100,000 kilometers is dramatic. Swap the coolant. Now go outside and look at your chain, because the way you tightened it is probably destroying a bearing you have never heard of, and replacing it requires pulling the entire gearbox out. 16. The chain tension truth. A chain running at minimum slack is a chain operating under constant elevated tension. Every revolution of the rear wheel applies that tension to the chain's side plates, the rivet heads, the sprocket teeth, and the output shaft bearing. The output shaft bearing in a Japanese inline-4 gearbox is not designed to sustain continuous elevated lateral loading. At minimum chain slack over extended mileage, output shaft bearing wear accelerates in a pattern that produces a distinctive whine at specific speeds, followed eventually by bearing failure that requires a gearbox removal to correct. Adjust to the center of the specification range. Lubricate with a quality wax-based chain. Lubricant applied to the inner surfaces of the chain where the rollers contact the sprocket teeth, not the outer plates where it flings off at speed and coats the rear tire. Inspect for stiff links after every wash. Replace the chain and both sprockets simultaneously, never one without the other. These 4 steps protect the output shaft bearing, the most expensive chain drive component that never appears in a standard chain maintenance guide. Chain sorted. Good. Now we need to talk about the service that most riders deliberately avoid because of the labor bill, and why that avoidance is writing a much larger bill that is currently compounding interest inside your cylinder head. 15. The valve clearance reality. Japanese engineers specify valve clearance check intervals in the service manual. They are almost universally ignored because the process requires removing bodywork, the fuel tank, and the cam cover on most modern machines, generating a labor bill that makes most riders defer the service indefinitely. Here is the reality those riders are missing. A valve running with insufficient clearance, tighter than specification, does not close fully at operating temperature. A valve that does not close fully allows combustion gases to leak past the valve face, overheating the valve head and burning the valve seat. This damage is irreversible without a cylinder head rebuild. The symptom is a gradual loss of compression that presents as harder starting, reduced power, and eventually a misfire. By the time it is diagnosed, the repair cost is multiple thousands of dollars. A valve running with excessive clearance produces an audible ticking that progressively damages the valve tip and rocker arm contact surface. The damage here is also cumulative and eventually expensive. Japanese technicians at Honda's internal maintenance facilities check valve clearances at every 3rd oil change on high-revving engines. Not every 3rd service interval, every 3rd oil change. The precision and consistency they apply to this single measurement, performed with a feeler gauge set to 4 decimal places of a millimeter, is the primary reason factory fleet engines reach mileage figures that independent mechanics consider impossible. Valves in check. Now imagine your engine's 4 cylinders are singing 4 completely different songs simultaneously, and you have been sitting on the vibration for so long, you think it is normal. Secret 6 fixes that, and the difference will make you feel like you bought a new motorcycle. 14. The throttle body synchronization secret. On any motorcycle equipped with multiple throttle bodies, specifically any inline-4 or parallel twin with individual throttle bodies per cylinder, the vacuum balance between cylinders drifts gradually as throttle butterflies wear, as intake rubber deteriorates, and as carbon deposits alter airflow characteristics. The drift is invisible to the rider in the early stages. It presents as a vague roughness at idle, a slight vibration at motorway cruise, and a sense that the engine is not quite as smooth as it once was. Japanese factory tuners synchronize throttle bodies at every major service using a mercury manometer or electronic vacuum gauge set. The process takes approximately 45 minutes on a fully warm engine with all systems at operating temperature. The result is an engine that idles with the mechanical smoothness of a sewing machine, pulls cleanly from any revs without surge, and consumes fuel with a consistency that improves economy by measurable percentages. On a carbureted machine, slide synchronization and needle height matching achieve the identical result. The process is identical in principle and equally ignored in practice by the majority of riders who attribute the resulting roughness to vague notions of the engine getting old. Engine singing in harmony. Wonderful. Now we are going to discuss the one component that is silently plotting to leave you brakeless at the worst possible moment, and it has been planning this betrayal since the day you bought the bike. 13. The brake fluid contamination clock. Brake fluid is hygroscopic. It absorbs moisture from the atmosphere through microscopic permeation of the rubber reservoir cap, the flexible brake hose walls, and the master cylinder seal faces. This is not a fault of the system. It is a chemical property of glycol-based brake fluid that every Japanese engineer accounted for in the maintenance schedule. Japanese factory protocol replaces brake fluid on a calendar interval, not a distance interval. Every 2 years, regardless of mileage, regardless of how the lever still feels. Bleed the system completely until fresh, uncontaminated fluid emerges consistently from the caliper bleed nipple. This single act is responsible for preventing a category of brake failure that is catastrophic, entirely predictable, and entirely preventable. Brakes sorted. You are welcome. Now let us talk about the $12 device that is protecting every single sensor and injector on your motorcycle, and the majority of riders do not even own one. The ones who do are laughing at everyone else's repair bills. 12. The battery charging discipline. Japanese motorcycle electrical systems are designed around a battery that maintains a resting voltage of 12.8 volts or above. Every sensor, every injector, every ignition coil, every ECU in a modern Japanese motorcycle produces its most accurate output when operating voltages at or above that threshold. Below 12.4 volts, fuel injector pulse width calculations become imprecise. The ECU compensates with enrichment corrections that run the mixture slightly rich. Below 12.2 volts, ignition coil charge time becomes insufficient at high revolutions, producing misfires that are frequently misdiagnosed as carburation problems, throttle body faults, or spark plug deterioration. Below 11.8 volts, the ECU on many modern machines enters a protection mode that deliberately limits engine output to reduce electrical load. A $12 smart charger, connected whenever the motorcycle is not in use, maintains every electronic system in its calibration zone and extends battery life by years compared to batteries that are repeatedly cycled through deep discharge and slow recovery. The investment is trivial. The downstream protection it provides to injectors, sensors, and the ECU is immeasurable. $12, that is genuinely embarrassing value. But Secret 11 is about something most riders have never changed in their life, something that is currently degrading inside your forks right now as you read this, and making every corner you enter slightly more unpredictable than the engineer intended. 11. The fork oil overlooked interval. Telescopic fork oil degrades through two mechanisms that most riders never consider. The first is oxidation. The oil is exposed to oxygen trapped in the fork leg above the oil surface, and over time, the antioxidant additive package depletes. The second is mechanical shear. Every compression and rebound stroke forces the oil through calibrated ports in the damper rod or cartridge, physically breaking down the viscosity improver polymers in the oil's formulation. After 2 years or 20,000 kilometers, whichever arrives first, the fork oil in a standard telescopic fork has a measured viscosity that is typically 1 to 2 grades below its original specification. Forks filled with 10-weight oil are performing like 8-weight oil. The result is a front suspension that rebounds faster than designed, reducing the contact time between tire and road surface during critical braking and cornering transitions. The rider experiences this as a vague, slightly nervous front end that they adapt to gradually and dangerously, never recognizing that the progressive change has degraded their safety margin. Japanese suspension engineers specify fork oil changes on the same calendar as coolant, every 2 years. Independent surveys of fork condition at service shops suggest that fewer than 15% of riders on machines over 3 years old have ever had their fork oil changed. The remaining majority are riding on degraded suspension that the manufacturer never intended them to experience. Now, Secret 10 is about a test so simple it requires 0 tools, 0 equipment, and 0 mechanical knowledge. Yet it catches an engine problem that costs thousands if you miss it. Most riders fail the test without realizing the test is even happening. 10. The air filter weight test. Japanese engineers designed the air filter maintenance interval around a paper element that, when new, weighs a specific amount and flows a specified volume of air at a calibrated pressure differential. The engine management system, whether carburetor needle position or fuel injection mapping, was calibrated against a clean filter's airflow characteristic. A partially blocked air filter does not simply reduce power, it alters the pressure differential across the filter medium, changing the effective air-to-fuel ratio the engine experiences at every throttle position. A filter that is 30% blocked by dust, pollen, and oil mist from the crankcase breather is running the engine richer than the calibration intended. This raises fuel consumption, raises exhaust gas temperature, and accelerates carbon deposit formation on valve heads and piston crowns. The Japanese test for air filter condition is tactile, not visual. Remove the filter. Hold it up to a light source. If you can see clearly defined light through the pleated element, the filter has acceptable flow. If the light appears uniformly dim, or if the pleats have collapsed in any section, the filter requires immediate replacement. The visual inspection most riders perform, looking at the filter surface from above in poor workshop light and deciding it looks acceptable, is insufficient because surface color does not accurately reflect internal pleat loading or total airflow restriction. Filter check the right way. Now step outside and look at your tires, because there is a pressure check mistake so widespread and so confidently performed that riders are doing it wrong, congratulating themselves for doing it right, and slowly destroying their tires and handling simultaneously. 9. The tire pressure. Thermal reality. Every tire manufacturer specifies tire pressures measured at ambient temperature, meaning the tire has been stationary for a minimum of 3 hours and has not been ridden. This is the cold pressure. It is the number printed on the tire placard on the swing arm. It is the number the engineers used when they designed the steering geometry, calculated the contact patch dimensions, and validated the braking performance. After 30 minutes of highway riding, tire pressure increases by between 3 and 6 psi above the cold setting due to heat generated by flexion. This is normal and expected. The critical error that Japanese engineers observe in rider maintenance habits is checking and adjusting tire pressure on a hot tire. A rider who checks pressure after a run finds it reading 3 psi above specification and releases that pressure to reach the specified figure has set their cold pressure 3 psi too low. When the tire cools, it will sit 3 psi below the engineering specification. The contact patch will be wider than designed. Handling will be imprecise. The tire will wear in a cupped pattern across the shoulder. Check tire pressure cold every time without exception before every ride if possible. The 2 minutes this requires is the most high-value time investment in your entire pre-ride routine. Pressures set correctly. You are genuinely doing better than most. But Secret 8 reveals a free diagnostic tool that your engine has been offering you at every service, and you have been throwing it in the bin without reading it. 8. The spark plug reading discipline. A spark plug is a diagnostic instrument. The color, texture, and deposit pattern on the center electrode and porcelain insulator of a used spark plug contains more accurate real-world information about engine combustion quality than most diagnostic computers can provide. Japanese factory technicians read spark plugs as a routine diagnostic step at every service interval. Most independent mechanics and almost no riders ever perform this analysis. A plug with a light tan to gray insulator, dry deposits, and a sharp electrode edge confirms correct combustion temperature, correct air-to-fuel ratio, and correct ignition timing. A plug with a white or light gray insulator with a clean appearance suggests a lean mixture or excessive heat. A plug with black, sooty, dry deposits indicates a rich mixture or incomplete combustion. A plug with oily black deposits indicates oil consumption that requires immediate investigation. Japanese engineers designed this diagnostic tool to require no specialized equipment beyond the ability to remove a plug and examine it under natural light. The information it provides is irreplaceable and free. Ignoring it converts a 5-minute diagnostic tool into an expensive workshop visit when the underlying condition it would have detected progresses to component failure that cannot be reversed. Read the plug. Read it. Now, Secret 7 is about a $30 tool that catches a failure mode so expensive and so catastrophic that the average rider who skips this check essentially hands their bank account to their mechanic on a silver platter, every 2 years, without fail. 7. The coolant system pressure test. The Japanese factory coolant system pressure test is performed at every major service interval, and it identifies a category of failure that is invisible to visual inspection and produces no codes on a diagnostic computer until the damage is already done. The test requires a cooling system pressure tester, a hand pump tool that attaches to the radiator cap neck and pressurizes the system to the radiator cap's rated release pressure, typically between 1 and 1.2 bar. The system is pressurized and observed for 60 seconds. Any pressure drop indicates a leak. Small leaks from a degraded water pump seal, a micro crack in a coolant hose, or a weeping cylinder head gasket joint produce pressure drops that are measurable with this tool before they produce any visible coolant loss or overheating event. A weeping head gasket detected at this early stage costs a gasket set and 2 hours of skilled labor. A head gasket that fails completely because the weeping was never detected costs a cylinder head machining operation, a new head gasket set, new head bolts, and potentially a cracked or warped cylinder head that requires full replacement. The pressure tester costs $30. The difference in total repair cost is catastrophic and entirely avoidable. $30. Remember that figure, because Secret 6 is about a 40-minute job that most riders have never done once in their entire ownership history, and the slow, silent deterioration it causes makes the motorcycle progressively harder to ride without the rider ever identifying a single specific symptom. 6. The grease point calendar. Every Japanese motorcycle contains between 8 and 14 grease points that appear in the service manual under a heading that most riders flip past because the items listed seem minor. Steering head bearings, swing arm pivot bearings, rear suspension linkage bearings, brake pedal pivot, gear change lever pivot, throttle tube bearing surface, side stand pivot. These points are not listed because they wear quickly. They are listed because when they dry out, they do not announce their deterioration audibly or visibly until the wear is severe. A dry steering head bearing produces a handling imprecision that develops so gradually the rider adapts without noticing. A dry swing arm pivot bearing produces a lateral compliance in the rear end that the rider interprets as tire behavior. A dry suspension linkage bearing produces stiction in the rear shock that dramatically alters the suspension's response to small road imperfections. Japanese factory maintenance protocol greases every pivot and bearing point with the correct specification grease, which is lithium complex or moly-based depending on the specific application and operating load, every 2 years regardless of mileage. The entire procedure takes 40 minutes with the correct tools. The cumulative effect on handling precision and component longevity over 10 years of continuous ownership is enormous. Now, Secret 5 is about a chemical process happening inside your fuel tank. Right now, if your motorcycle has been sitting for more than 60 days and the damage it leaves behind is invisible until the day your engine refuses to start and you are standing in a car park at 7 in the morning wondering what went wrong. 5. The fuel system stale fuel protocol. Ethanol blended petrol, which is now the default fuel standard in most markets, has a storage stability window of approximately 60 days before the ethanol begins to phase separate from the hydrocarbon fraction. Phase separation in a motorcycle fuel system deposits a water and ethanol mixture at the lowest point of the fuel circuit, the float chamber base, the fuel injector filter basket, and the fuel pump inlet screen. Japanese factory technicians who prepare motorcycles for storage or extended periods of inactivity follow a precise stale fuel protocol. The fuel tank is either drained completely or filled to 100% capacity and treated with a fuel stabilizer approved for ethanol blend petrol. The fuel system is then run at idle for 3 minutes to distribute the stabilizer through the entire fuel circuit. The petcock, where fitted, is turned to prime briefly and then to off to evacuate the float chamber of unstabilized fuel before the final shutdown. A motorcycle stored for 3 months with a partially filled, untreated tank in a market using 10% ethanol blend fuel will develop float chamber varnish deposits, injector filter blockages, and fuel pump mesh contamination that collectively devastate cold start performance and fuel delivery consistency across the entire rev range. The stale fuel protocol costs nothing but awareness and 5 minutes of preparation before shutdown. Fuel stabilized, Excellent call. But Secret 4 is about a failure mode so slow and so invisible that your ECU has been compensating for it for years without telling you, quietly making increasingly incorrect decisions about your engine based on data that oxidation made up. The fix costs under $10. The ignorance costs the entire fuel and ignition system. 4. The electrical connector oxidation treatment. Japanese motorcycle wiring harnesses are engineered to the most exacting standards in the industry. The connector housings are precision molded. The terminal crimps are pulled to specification force. The wire gauges are calculated to the exact current load of each circuit. And none of that engineering survives 20,000 kilometers of vibration, thermal cycling, and atmospheric humidity without one specific maintenance intervention. Every electrical connector in the weather-exposed areas of a Japanese motorcycle, the connector blocks at the rear tail unit, the sensor connectors along the frame backbone, the instrument cluster connections at the headstock, must be disconnected, inspected, treated with a dielectric grease or an approved contact cleaner, and reconnected every 3 to 4 years. Oxidation on copper terminal surfaces increases contact resistance. Increased contact resistance reduces voltage at the load. Reduced voltage at sensors means inaccurate readings sent to the ECU. The ECU makes fuel and ignition corrections based on false data, and the engine runs in a perpetual state of partial miscalibration that no fault code ever illuminates. Japanese technicians carry small syringes of dielectric grease and treat every connector they open as a routine habit that requires no additional time allocation. The total cost of this intervention is under $10 annually. The effect on electrical system integrity and sensor accuracy over a full decade of ownership is profound and largely invisible because the problems it prevents never materialize. Connectors sealed. You are an electrical genius now. Secret 17 is about the component at the front of your engine that riders clean with a high-pressure hose from the wrong direction, calmly destroying it while believing they are performing exceptional maintenance. The cleaning technique is everything. 3. The radiator core flow inspection. The radiator on a liquid-cooled Japanese motorcycle is designed to a specific airflow target through the core fins. The engineers calculated the cooling capacity, assuming a percentage of those fins remain unobstructed over the service life of the machine. Most riders who examine their radiators do so from a distance of 3 feet and consider a visual inspection complete if the fins appear undamaged. The Japanese factory standard for radiator inspection involves examining the core at an angle with a light source, specifically to identify fin sections where debris, crushed insects, dried mud, or mineral deposits from water washing have reduced airflow through the fin stack. Sections where the fins are matted together by debris represent a local reduction in cooling capacity. If those sections correspond to the area directly in front of the cylinder head coolant outlet passage, the temperature differential between the coolant entering and leaving, that section of the radiator is elevated beyond design specification. The cleaning method is precise and non-negotiable. A soft bristled brush used strictly in the direction of the fin orientation, never across it, combined with low-pressure water applied from the back of the radiator forward, never from the front face, which drives debris deeper into the core and permanently collapses fin sections. A correctly cleaned radiator restores the full cooling margin the engineers designed into the system and prevents the gradual thermal creep that causes premium Japanese engines to run measurably warmer every year without any single identifiable cause. Radiator clean, thermals restored. Now, Secret 2 is about a step that happens after the service is technically finished, one that virtually no home mechanic and shockingly few professionals ever perform, and whose absence is responsible for a quiet epidemic of failures that workshops blame on everything except the real cause. 2. The torque verification principle. Japanese engineers design fastener torque specifications around a specific clamp load, the compressive force that holds 2 surfaces together under operational loads. The torque figure is not an aesthetic preference. It is a calculated value that, when applied to a specific fastener with a specific thread pitch and a specific material, produces a specific clamp load that keeps the joint secure under the vibration frequencies in thermal cycling that the assembled component experiences in service. The critical maintenance principle that Japanese factory technicians apply and that virtually no independent mechanic or home mechanic applies consistently is retorquing. When an aluminum component has been removed, subjected to a heat cycle, and refitted, the initial torque applied during reassembly stretches the fastener slightly. After the first heat cycle, the bolt settles into its seated position and the clamp load reduces. Japanese factory protocol retorques critical fasteners, specifically cylinder head bolts, engine mounting bolts, and exhaust header bolts, after the first heat cycle following any reassembly. Missing this retorque step is responsible for a significant and documented proportion of the head gasket failures, exhaust header leaks, and engine mount fretting that independent workshops routinely attribute to general age and wear, when the actual cause is a single missed procedure during the previous reassembly. Radiator clean, thermals restored. Now, Secret 18 is about a step that happens after the service is technically finished, one that virtually no home mechanic and shockingly few professionals ever perform, and whose absence is responsible for a quiet epidemic of failures that workshops blame on everything except the real cause. Retorque done. You are officially thinking like a factory technician. Now, the fifth Siret, the one that kills more healthy Japanese engines than all the others combined. The one you do every time you park the bike. The one you have almost certainly been doing wrong since the day you started riding. This is the one. 1. The Japanese engineer's single most important secret. This is the secret that Japanese factory technicians consider the highest priority maintenance act in the entire service protocol. The one that appears in every internal training document, every factory technician refresher course, and every quality audit checklist. The one that most riders perform incorrectly on every single occasion without ever knowing it. It is the engine oil level check. Not because riders fail to check it, most riders check it, they perform it incorrectly. Every Japanese motorcycle manufacturer specifies in the technical documentation that the oil level must be checked with the motorcycle vertical, on a level surface, engine off, having sat undisturbed for a minimum of 5 minutes after the last engine operation, with the engine at operating temperature. 4 conditions, every single one is critical. Vertical, a motorcycle on its side stand tilts the crankcase. The oil pools toward the left side. The sight glass or dipstick reads incorrectly. Adding oil to a level that appears low when the motorcycle is on its side stand will overfill the sump when the motorcycle is held vertical. Level surface. A surface with even a 3-degree slope alters the oil surface height in the crankcase by enough to produce a false reading at the sight glass. 5 minutes after shutdown, the oil pump has a residual pressure that holds oil in the galleries, the filter, and the upper engine. It takes a minimum of 5 minutes for all circulated oil to drain back into the sump. Checking immediately after shutdown produces a low reading. Adding oil to correct that reading will overfill. Operating temperature. Cold oil is denser than hot oil. A cold oil level check on a full sump reads higher than the actual hot level. A hot oil level check after proper drainage time gives the only accurate reading. An overfilled engine is not a safely lubricated engine. Excess oil in the sump contacts the crankshaft counterweights at operating speed. The rotating assembly aerates the oil, whipping it into a foam. Aerated oil cannot maintain hydrodynamic film thickness across bearing surfaces. Bearing damage from oil aeration looks identical to bearing damage from oil starvation. Mechanics see the damage and conclude the engine had insufficient oil. The engine had too much. The rider had been topping up correctly on a cold engine, on a side stand, reading a sight glass that was lying to them every single time. This is the secret that kills more healthy Japanese engines than any other single maintenance error. Performed correctly, the oil level check is a 5-minute ritual that gives you complete confidence in the most critical lubrication system on the machine. Performed incorrectly, it is a slow, invisible, catastrophic engine destruction program that the rider administers to themselves, service by service, until the bearing shells fail. Every other secret on this list extends the life of your motorcycle. This one, performed correctly, guarantees it. If you stayed with us till now, click the next video on your screen right now to continue the journey. Stay sharp, stay informed, and I will catch you there.